A seaplane alights the water. A family on an outing sails past it in the foreground. Watercraft and seacraft alike share the same waters simultaneously. A common sight in Seattle and other locations in the U.S. However, in Europe, due to incompatible regulations between nautical and aeronautical restrictions, the peaceable coexistence of watercraft and aircraft sharing the same aquatic surface is impossible. Prior to the Second World War, flying boats carried out nearly all long-haul air transport. The reason? They allowed one to travel all over the world. The only things necessary to operate? A surface of still water, a simple infrastructure, and features more akin to boats. Nothing else was necessary. However, the beginning of the end of seaplanes started with meteorological research, pressurized aircrafts, and engine-forced induction compression. Systematically, the outbreak of World War II, the launching of the 1944 Chicago Convention, and the British Barbizon Committee all led to seaplanes being superseded by other forms of transport. From that moment on, seaplanes would never be the same again. In the 1980s, seaplane operators began to develop new projects. During these years, seaplanes were flown with the same passion and for the same reasons as they were in the early days of aviation, connecting far-off lands where rivers and lakes provided natural alighting surfaces. Only seaplanes could tap into this niche market, which continued to be their advantage until today. From the beginning, land plane models were used to manufacture seaplanes by simply converting their undercarriage into floats. But by the end of the 1980s, new innovations began to come into being. Nowadays, there's a worldwide resurgence of airlines using seaplanes on scheduled and tourist flights, worldwide excepting Europe. The reason? The lack of agreement between port and maritime authorities and aeronautical administrations. Regulatory policies in all areas have become a hornet's nest of rigid European regulations preventing any envisioned enterprises in these areas of transport. Enter the wigcraft. A unique vessel which has its origins in the aeronautic industries. Researched and developed by Dr. Alexander Lepich, the wigcraft is the result of an aerodynamic effect on the reverse delta wing. Lepich, considered the father of the delta wing, developed several projects of specially designed aircrafts which made the most of the ground effect. His aim was to develop a very low-level flying aircraft, able to avoid radar detection and launch surprise attacks. This was the case with the delta-winged Mirage 3C in the Six-Day War of 1967. After hedge-hopping at a very low level over the sea, the fighter aircraft purposely ascended high enough that it could be detected by Egyptian radar. Then, the Israeli Air Force calculated the time it would take them to reach the main Egyptian air bases immediately after being detected. This enabled them to bombard the Arab League's fighter aircrafts just as they began their takeoff, obliterating most of them and damaging the runways. And surprisingly, these hair-raising low-level flights were carried out in a much safer manner than expected. The Mirage 3 took full advantage of the ground effect of its delta wings. The first ground effect aircrafts developed by Leapage shared the same principle of all wigs, i.e. that a good ground effect aircraft is a bad fixed-wing aircraft, and in turn, a good fixed-wing aircraft is a bad ground effect aircraft. However, because these aircrafts were cataloged and registered as airships, it prevented them from entering the market. Surprisingly, the West did not maximize this scientific knowledge. The project reached its zenith with Restylov Alexeyev, a Russian scientist in the Soviet Union. The aircraft were known as ekranoplanes, from the Russian word for ground effect, or Ekranly effect. They shared Leapage's delta wing concept, but had a trapezoidal wing platform. Currently, Russia is light years ahead in the development of these programs, as they've been used in their military applications for more than half a century. In the latter years of his life, Leapage worked alongside Hanno Fischer. Hanno Fischer was the technical director of Rhein Flugzeugbau, a German company that designed and manufactured wig crafts. In 1979, Fischer, along with Klaus Madjasik, founded Fischer Flugmechanik. The company's aim was to design and commercialize wig crafts, now classified as ships. The West followed the Soviet Union's example of the ekranoplanes, which had emerged from naval engineering. The limitations of the wig crafts are obvious. It's not a plane and therefore can't operate in valleys, mountains, and rugged areas. Neither can it fly very high, and therefore can't be used as an observation platform. The swell, wind speed, and height of obstacles are also limitations. Keeping in mind these restrictions, specific topographical areas can't be considered. But the wig craft boasts many attractive advantages, which understandably have generated interest worldwide. One of its most salient features is that its operational costs are 40% lower than that of equivalent seaplanes. Speed is another one of its great benefits, as it flies at the same velocity as an equivalent seaplane. And a truly remarkable advantage is its classification, not as an airship, but as a ship, which places it within the laws and regulations of the sea. The IMO, International Maritime Organization, is the United Nations Organization for Maritime Transport. It's the equivalent of the ICAO in air transport. Since the approval of IMO's Maritime Safety Committee guidelines in December 2002, wig crafts are legally considered high-speed ships. Owing to this classification, wig ship commanders are not required to be pilots, and the craft itself is not subject to stringent aircraft maintenance regulations. In being certified as a ship, it does not require an airworthiness certificate, a permit both difficult and expensive to obtain. Due to its recent technology, the wig lacks market experience, but that's changing. The North American Pacific Sea Flight was the first passenger transport company in the world to employ wig ships. Since 2003, they've operated high-speed passenger ferry services from the United States to Alaska's Inside Passage. The wig model used is a Russian model Evolga. The North American company Wigcraft Design Blue Dolphin has commercialized this model. However, Hanno Fischer's products are dominating the market. After the development of Airfish 8, which was certified as a ship in 2010 and is superior to the Evolga, Fischer's company developed an even more advanced technology, which made Airfish 8 obsolete almost overnight. Hoverwing technology. Developed as a means to improve sea transport, hoverwing technology emerged in 1996 via the German Ministry of Research and Development. Currently, Germany is endeavoring to fashion an 80-seat hoverwing for the Baltic Sea. This new wig ship has the distinctive feature of forming a guided airstream in between its catamaran floats, generating an air cushion equivalent to 80% of its weight and increasing fuel efficiency during taxi and takeoff. South Korea is presently certifying the Hoverwing 50, a 50-seater craft which will operate a 40-minute route between Gunsoon and Jeju Island with 4 crafts. And, depending on the success of the Wig Ferry, South Korea will increase the number of routes between itself and Japan. Until now, conflicting regulations from aeronautical and shipping restrictions have thwarted seaplane usage in Europe and in turn kept all commercial prospects unrealized. One of the Wig's most unique aspects is that in addition to its cutting-edge technology, its unique classification as a ship bypasses those contradictions. It enables European enterprises to profit from the untapped cargo and passenger transport opportunities that exist from the Baltic Sea to the Mediterranean to the whole of Europe's west coast. Its time has arrived.